Raman High School, the pioneer of IIT Foundation in Tri-Cities.
So now let us see what are the prime numbers and composite numbers. Already have learned about prime numbers and composite numbers in your previous classes, in 6th and 7th classes, and before that. You might have learned about prime numbers and composite numbers. Now let us revise that. According to your definitions, or according to what you learnt before this, a prime number is a number with only two factors, and a composite number is a number with more than two factors. If a number have more than two factors, therefore it is a composite number. And there are different types of definitions for prime number and composite numbers. Prime number is a number which is divisible by 1 and itself, that is one definition. Or you can say a prime number is a number with only two factors, and a composite number is a number which will have factors other than 1 and itself. Or you can say a composite number is a number with more than two factors. If a number have more than two factors, it is a composite number. I think this you have already in your previous classes. Let us see the prime factorization of composite numbers, the numbers whose factors are more than 2. So let us take a composite number 24 and let us write the prime factorization of that. Here 24, and let us take its prime factorization. Here 2 divides 2 6 times, 2 3 times, 3 1 times. Therefore, the prime factorization of 24 is 2 into 2 into 2 into 3. Here 2 into 2 into 2 into 3 is the prime factorization of 24. Now, let us take some other number, 18. Here 2 9s are 3 times, 3 1 time. Now let us write the prime factorization of 18, that is 18 equals to 2 into 3 into 3. So this is what already have in your lower classes. The prime factorization of a number already know. And 24 prime factorization is this one, and the 18 prime factorization is this one. So a composite number is written as product of prime numbers. And you see, this product of primes can also be written like this: 2 into 3 into 2 into. Just have changed the order. If you change the order of prime factors, is there any change in the product? No, because 2 into 3 into 2 into 2 is also 24. If you change the order of prime factors, the product does not change. Here also you can change the order of prime factors. 2 into, otherwise 3 into 2 into 3. Here I have changed the order of prime factors. Also, the product does not change. Here 3 into 2 into 3 is again going to be 18. From this we can observe that while writing the prime factorization of a composite number, the order of prime factors what we are writing is not important. Whatever the order we are writing, the product will be same. So whenever we are taking the prime factorization of a composite number, the product of prime factors can be in any order. That will be changing from person to person. Some student may start prime factorization with 2, some other student may start with 3. So the prime factorization will vary. So like this, here I have written 2 cases. You can write in some other way for some different numbers. So here we have observed that the prime factorization of composite numbers is a product of prime factors, and the product of prime factors can vary in their order. So based on this concept, we have a theorem, that is fundamental theorem of arithmetic. According to fundamental theorem of arithmetic, every composite number can be expressed as product of primes. This factorization is unique apart from the order in which the prime factors occurs. Here this statement is important. The order in which the prime factors occurs. Here order is changed but the product is not defined. The product is always same. Therefore these two are not different products. So these two are the same. That's what we are saying. This prime factorization is unique. So by using these examples we can understand that every composite number can be expressed as a product of primes, and that product of primes or that factorization is always unique. Whatever the order, the prime factors they are occurring. So here the order of prime factors, what we are saying is not important because the product will not change. Okay, so this definition is important for 1 mark questions in the SSC board examination. You have to remember this statement, and sometimes they will ask define fundamental theorem of arithmetic, give an example. For that you have to write this statement, that is every composite number can be written as product of primes, and this factorization is unique apart from the order in which the prime factors occur. And you can take an example like this and you can say that every composite number can be written as product of primes. By using this fundamental theorem of arithmetic, we can verify whether the given number is a composite number or not. In this 10th class, we are going to take some numbers and we are going to verify whether the given number is a composite number or not. And let us see some examples of composite numbers or some numbers, whether they are going to become composite numbers, whether they are going to be composite numbers or not. Now let us see this example and verify whether this is a composite number or not. Here plus sign is there and 13 and 13 is there. You can take 13 as common factor. 7 into 11 plus 1. Here 7 times 11, it is 77 plus 1, and 13 into 78. Here 78 prime factorization you can take, and that is 13 into, here 2 times 39 it will come, 2 times 39, and 13 into 2 into, here 13 3s are 39, 3 into 13 you can write. So the prime factorization of 7 into 11 into 13 plus 13 is 13 into 2 into 3 into 13. So the given number is written as product of primes. Therefore, according to fundamental theorem of arithmetic, 7 into 11 into 13 plus 13 is a composite number because the given number is written as a product of primes. That's what it is, a composite number. In fundamental theorem of arithmetic, we learned that if there is a composite number, that composite number can be written as product of primes. Here, based on that fact, we have factorized this and we are able to write as a product of primes. Therefore, the given number is a composite number. Therefore, 7 into 11 into 13 plus 13 is a composite number. Now let us see how to find out the LCM and HCF of given numbers by using prime factorization method. This prime factorization method already have in 6th and 7th classes. However, we are going to revise that. Here I am going to take 12, 18 as two numbers and I am going to find out their LCM and HCF by using prime factorization method. Let us take 12 and write its prime factorization. 2 6 times, 2 3 times, 3 ones are. Therefore, the prime factorization of 12 is 2 square into 3. Here 2 into 2 it is a 2 square. 2 is occurring for 2 times, that's why 2 square. Here 3 is occurring only for once. And let us take the prime factorization of 18. That is 18. 2 9s are 3 3s and 3 one time. The prime factorization of this one is 2 power 1 into 3 power 2. Now we have the prime factorization of 12 and 18. By using this prime factorization, we are going to find out the LCM and HCF of these two numbers 12 and 18. And first of all, let us see what is LCM. How to find out LCM from this prime factorization. To find out the LCM of two numbers, we will take the greatest powers of all the prime factors in the numbers. Here, in 12 and 18, we have 2, 3 as the prime factors. You have to see only bases here. Here 2 is a prime number, 3 is a prime number. Here we have only two different types of prime numbers. Two different prime numbers. They are 2, 3. For those prime numbers, you have to take greatest powers. So here 2 power 2 and 2 power 1. In that you have to consider greatest power of 2. And here 3 power 1 and 3 power 2. In this you have to consider greatest power. Therefore, 2 square it is 4, 3 square it is 9 and it is 36. Therefore, the LCM of 12, 18 is 36. And let us see how to find out HCF from this prime factorization. While taking HCF of two numbers, we will consider only common prime factors. Here in these two numbers, the common prime factors are 2 and 3 is also a common prime factor. For that common prime factors, you will take the least powers. To find out LCM, for all prime factors, we are taking highest powers. But to find out HCF, for only common prime factors, you will take least powers. Here 2 power 1 and 2 power 2. In this we have to consider only least power. Here 3 power 1 and 3 power 2. In that you have to take the least power. Therefore 2 3s are 6. Here LCM is 36 and HCF is 6. So let us revise this. Let us see once again. You want to find out the HCF of 12, 18. First you have to write the prime factorization of those two numbers. After taking their prime factorization, to find out the LCM for all prime factors, you have to take the greatest powers and multiply. To find out the HCF for only common prime factors, you have to take the least powers and you should find out their product. That is what you have to remember. The important thing is to find out LCM. For all prime factors, you have to take greatest powers. To find out HCF, you have to consider only common prime factors and their least powers. Now let us see one more example. Suppose there is a number A and its prime factorization is 2 cube into 5 square into 7. And B is another number, that is 2 square into 3 power 1 into 7. Nothing but 7 power 1. Here A, B are two numbers and their prime factorizations are already given. How to find out their LCM and HCF? Here LCM. Here I said that to find out LCM, you have to consider the greatest powers of all the prime factors. Here 2 is a prime factor. For the greatest power we have to take here 2 power 3, 2 power 2. Here greatest power is 3. Here power is 3, power is 2. Greatest is 3. And here 3 is a prime factor. Here in this only one time we have 3 power. Therefore 3 power 1. Here 5 power 2. Here we don't have 5 power something. Therefore the greatest power of 5 is 5 power 2 itself. and here 7 power 1 and 7 power 1, greatest power we have to take for 7 also, therefore 7 power 1. That is the LCM. If you find out that product, you will get the LCM. Now let us see how to find out HCF. Here I said that to find out HCF, you have to consider the least powers of common prime factors. Common prime factors you have to note. Here what are the common prime factors? Here 2 is a common prime factor. For that we should take least power, 2 square. And here 5 is not a common one, 3 is not a common. And after that we have 7 as common. Its least power you should take, the least power is 1. Therefore 2 square into 7 is the HCF. So this is the method of calculating LCM and HCF using prime factorization. So in this process, let us observe one thing. Let us find out the product of these two numbers, 12 into 18, and also find out the product of this LCM and HCF. LCM and HCF we are multiplying here. What is LCM? Here the LCM is 36 and HCF is 6. You are getting 216 here. Here 12 into 18, product of numbers, that is also 216. Here the product of numbers is 216. The product of their LCM and HCF is also 216. From this we can conclude that if you have two numbers A comma B, the product of A comma B, the product of two numbers A comma B is equals to LCM of A comma B into HCF of A comma B. If there are any two positive integers, the product of those positive integers will be equals to their product of LCM and HCF, the product of their LCM and HCF. Suppose if you have A comma B two numbers, and if you take LCM as L and HCF as H, we can write a relation as product of two numbers equals to L into H. Here A into B is equals to L into H. LCM into HCF equals to product of two numbers. This fact can be extended to more than two numbers, but we shall not discuss here. That you will learn in higher standard. So now let us see a new concept, that is when a given number is going to end with the digit 0. And let us see 10 and its prime factorization. 2 into 5. Let us take 20. Here I am taking 10, 20 because it is ending with 0. And let us take the prime factorization of this. 2 square into 5 and 30. 2 into 3 into 5. And here 40. 2 into 2 power 3 into 5. So you can take like this. And you can observe one thing in these all prime factorizations, that a number is ending with a digit 0 because their prime factorization is including the prime factors as 2 and 5. Here in every prime factorization you can see there is a prime factor 2 and 5. Here 2 and 5, 2 and 5, 2 and 5. That's what they are ending with the digit 0. So we can observe that if a number to be ending with a digit 0, compulsory its prime factorization should contain the prime factors as 2 and 5. Okay, now let us see an example. Here in your textbook you have this one as an example. You have to check whether 4 power n ends with a digit 0 or not. We have to check whether 4 power n is ending with a digit 0 or not. To check whether it is ending with a digit 0 or not, you have to write its prime factoration. Let us take 4 power n. Here for 4, prime factoration is 2 square. Here power n is there. Here 2 into n, 2n. And for 4 power n, the prime factoration is 2 power n. And we are going to check whether 4 power n is ending with the digit 0 or not. According to this fact, a number ends with the digit 0 if and only if its prime factoration includes 2 and 5. But here, in the prime factoration of 4 power n, there is only 2 as a prime factor, there is no 5. Therefore, 4 power n does not end with the digit 0. That is what you have to write. Here, the prime factoration of 4 power n contains 2 but not 5. Therefore, the number 4 power n does not end with the digit 0. And again, one more number let us take here. Check whether 3 power n plus 4 power m ends with the digit 0 or 5. Before that, let us see when a number is ending with the digit 5. See, 15. Its prime factoration is 3 into 5. 25, 5 square. 35, it is 7 into 5. And here 45, that is a 3 square into 5. So in these all, you can observe every number is ending with a digit 5. And you can observe in the prime factorations, there is a prime factor as 5, but there is no 2. Because in a prime factoration, if there is a 2 and 5, then that should end with the digit 0. So in this, we can observe that there is no prime factor 2. That's what the numbers are ending with the digit 5. There is a prime factor 5, but there is no prime factor 2. That's what they are ending with a digit 5. This is what we have to observe before attempting this question. Now let us see this question. And let us verify whether this is going to end with a digit 0 or 5. For 0, you have to check this. The prime factoration should include the prime factors 2 and 5. For 5, the prime factoration should include only 5 but not 2. 3 power n into 4 power m. Let us write its prime factoration. Already 3 is a prime number. Let us write as it is. Here 4 can be written as a 2 square whole power m. That is a 3 power n into 2 power 2m. Here 2 into m. This is a prime factoration. Here the bases are prime numbers, therefore it's a prime factoration. In this prime factoration, we can observe that there is a prime factor 2 but not 5. Therefore, 3 power n into 4 power m does not end with the digit 0, because if the prime factoration includes 2 and 5, then only it ends with the digit 0. And one more thing, you can observe that in this prime factoration there is no 5. Therefore, we can conclude that the given number 3 power n into 4 power n does not end with the digit 5. So, in this problem we are learning that if the given number can be written as product of primes, we could say whether the given number is ending with a digit 0 or 5. Once again, let me revise. If the prime factoration includes the prime factors 2 and 5, then its last digit, otherwise the number will end with a digit 0. And if you see this, if the prime factoration of a number includes only 5 but not 2, then that number will be ending with a digit 5. Now let us see this example. What is the last digit of 6 power 100? Here Let us observe this pattern. 6 power 1 is 6, 6 power 2 is 36, 6 power 3 is 216, 6 power 4 that is 1296, and so on you can take. In all these we can observe here 6 power 1 is ending with 6, 6 power 2 is ending with 6, 6 power 3 is ending with 6, nothing but last digit units place is 6. Here 6 power 4 is also ending with the digit 6. From this we can conclude, if you take any power of 6, it is always ending with the digit 6. Therefore, the last digit of 6 power 100 is also 6. So we can conclude one thing. 6 power any positive power, you can take any positive power here, 6 power 1, 2, 3, 1 lakh, 2 lakhs, everything, anything. 6 power any positive power will always ends with the digit 6. Nothing but its units place will be always equals to 6. And there are different types of methods to calculate units place of a number. In your 10th standard you have this simple question, and if you want to learn about units places you can search in different books in number theory and you can learn. And with this problem I have concluded first two exercises, and I have explained each and every problem which is required to complete your first exercise and second exercise. Complete your first exercise, second exercise along with examples. Try this, do this, think and discuss. Everything must be done. So in the next class I am going to explain about rational numbers and their decimal expansions, irrational numbers and their applications, and logarithms and its applications. Thank you.